Okay, so why don't we get started? It is my pleasure to introduce Joy Walker, our presenter today. Joy has been part of City Colleges since 1982, when she began as a chemistry professor at Truman. She retired from Truman in 2017, and we have been fortunate to have Joy teach with us at Wright every semester since 2019, and she teaches chemistry and physical sciences. I've had the pleasure of getting to know Joy since I also started in 2019. And when she says teaching isn't what she does, it is who she is speaking truth. Her curiosity about the world informs how she constantly rethinks approaches to excite students about science as part of their lived experience. And I've been very fortunate that Joy has often sent me examples of things that she's doing and how students are responding, and it's wonderful. When Joy isn't doing this kind of thing and working in the classroom, she has many hobbies. She enjoys gardening with a focus on soil science, and she bakes. We often have had discussions about baking because she brings, of course, her understanding of science to baking. And these are just examples of how her vocation influences her relaxation. Joy is also an avid reader and is always happy to share recommendations, and a crafter, including painting and paper making. I could go on, but let's get to Joy's presentation. Chemistry your grandparents knew.
Great. Thank you for that introduction, Pamela. Okay, so I'm going to ask you to use the chat, and I'm going to be asking a couple of questions. So if you could figure out how you can text your answers. Text your answers to everyone, but do me a favor. When we do this first little activity, don't look at the chat until you've decided what word or phrase you are going to type. So we're going to play word association. I say a word, and we need to, Lookner, could everyone mute? Because I'm getting some background noise. Yeah, thank you so much for doing that. Thank you. Okay, so we're going to play a word association game. And the way that works, you know, is I say a word and you type in the chat the very first word or phrase that comes into your head. Are you ready? Chemicals. Okay, and as you type your words, take a look at what other people have typed, because it's always very interesting to do this activity. You'll see in the list of words that people have said danger. Several people have said dangerous. One person said magical, but she's a chemist, so I know that. And bad stuff, drugs, acids, stinky. Yeah, I used to see a phrase on the wall of a school, that my undergraduate college, that said something to the effect of biology wiggles and chemistry stinks. So, so there it is, the stinky science. What I want to do today is develop a theme with you. And one of the problems I've already run into is that as I was researching this topic, it got bigger and bigger and bigger. So I'm going to get through what I can in the time we have. But I do have, let me just start the share here. I do have references that you can go to in order to see where I got my material, and maybe to find more information if you so choose. So I've decided to focus on the time frame between 1930 and 1960. This seemed like, I mean, we don't all have grandparents with the same years of life. This would be roughly when my parents were growing up and when my grandparents were still alive. So it seemed like a good range. And this is the link, which I will put in the chat at the end of the talk, where you can find my resources and various other little extras from this talk. So as I was developing this, of course, I felt a lot of nostalgia because I was reaching back into my childhood memories, and I was thinking a little bit about how chemistry seemed to me through the eyes of a child and why I grew up to become a chemist and love chemistry. But one of the things that I realize as you research the past is that you don't always find the same things because you're looking at the past through the lens of the present and through the lens of the things that you've learned. So I want to set the scene a little bit for you. I am not very informed about history. History has never been something that I've studied very seriously, and I tend to get a lot of dates confused. So I sort of just pick some things at random to kind of define the 30s, the 40s, and the 50s. So right before 1930, we underwent an absolute revolution in science. It was the birth of quantum theory, and I can't even begin to say how much that changed our understanding of chemistry, but I'll just leave it at that. We also started television around the same time. And this was a result of our better understanding of different types of radiation. So in the 30s, you see that we were still trying to figure out particles like the neutron. We already knew about protons and electrons. So we're still basically figuring out atomic structure in this time. Einstein immigrated to the United States in the early 30s. We had the Dust Bowl, we had the Depression, but we also had the first canned beer. If that's a good thing or bad thing, I'll leave you to decide. The Hindenburg exploded, and that to me was very interesting because we may have been a world full of airships. We may yet be a world full of airships. But at that time, because we refused to share our relatively scarce source of helium with Germany, they filled the Hindenburg with hydrogen, and hydrogen is a flammable gas. So that's the story. Comic books were beginning to rise in popularity. Superman first appeared in the late 30s. Whoops. In the 40s, I would say it was primarily dominated by the war itself, and the world's first nuclear explosion was in 1945. Then the war ended, we came home, and there was an era of the development of convenience. And Julius Nadis will appreciate that I put here in 1951, the first business computer, the UNIVAC. And we were beginning color television. Color television was beginning to be in certain homes, certainly not all homes. I grew up with a black and white TV. And then at the end of the 50s, Sputnik launched, leading us down the path of the Cold War. 38 to 50s, golden age of science fiction. And I just I had a little aside here because there will be a tiny, you will see a tiny focus that comes in on the feminist angle. And the first American woman to win the Nobel Prize didn't happen until 2018. So that should suggest something. Some of the changes that happen over these decades is life went from being rural to slowly moving into cities, and then later on from the cities out to the suburbs. So there was a general change in lifestyle. People had a lot less contact with raw materials once they got off the farm, because if you are familiar with farm life, that puts you much more in direct contact with substances. They're all around you. Convenience appeared, including air conditioning, which would allow people to stay indoors and might be said to be the beginning of a sort of disconnect with nature. Thoughts about radiation changed significantly. As we first discovered radiation, it was amazing, wonderful, maybe a miracle. It could solve all your problems. And then as we begin to understand it better, we begin to fear it. And certainly that was epitomized by the dawn of the nuclear bomb age. Science was dominated by Caucasian men, but women were the experts in the kitchen, and they came to have a very narrow, glorified role as housewives that could do their own kinds of chemistry, their own kinds of wizardry. During this era, a scientist had a lot of respect. They were seen as saviors and heroes and geniuses and people that could just do anything and solve all the problems. And then following this era, we had the civil rights movement that dominated the 60s and the women's rights movement that was prominent in the 70s. And as you all know, and we've all become painfully aware, we're still fighting those battles. So here's just a little graph, and you can see what happened in 1945 when the war ended and people came back from the war. The population in the United States increased. That was known as the baby boom. But at the same time that it increased, the population living on farms decreased, and that trend has continued. So to separate these 3 decades, I would say in the 30s, women would bake bread, men would hunt, people lived on farms, they raised chickens. It was all about economy. It was all about reuse and stretching what you had available. Many medicines were based on plants. When the war decade occurred, during the war, there were a lot of shortages, and because of shortages, there were new inventions. And one of the interesting new inventions that happened in this era was that because of the shortage of lard, detergent was discovered, and detergent was based on petroleum instead of lard. And so detergent began to take over from soap. But soap was very, very prominent in the 30s, and there was a very interesting movement towards advertising soap in combination with entertainment, leading to the phrase like the soap opera. The Cold War, women were really literally pushed back into the home as men came home and needed those jobs. And so in order to sweeten that exclusion from the workforce, their role as the manager of the home was exalted. So what might you have encountered in those days? Well, here's some examples I came up with, but I'd like you to type in the chat some examples of your own as you read through this list. If you can think of anything in your earliest memories that might have been of a chemical nature. The arsenic was very commonly kept in easy reach because it was often used to kill rats, and everyone knows rats and mice are a problem whenever there's food and when you live close to the food and you have varmints. You also have a lot more machines that were simple enough to do your own repairs. I have an early memory of my father working on lawnmowers simply by flipping them over and taking them apart. And it was not unusual to have a garage full of all kinds of motor oils and very caustic cleaners. It wasn't unusual to do your own cement and concrete work. And houses were heated with coal. I mean, absolutely, the truck would come to your house. I talked to a friend of mine who remembers this as a child, and he said that he remembers the truck pulling up. They had a special window that they could open. They would attach the chute. The coal would come down the chute, and then it would be the family's job to shovel it into the coal furnace in order to keep the house heated. And that was in the 1940s in Chicago, in a Chicago home. Lead was everywhere. Lead was in gasoline. Lead was the metal was soft and easy to manipulate, so it could be put on tires in order to balance them. It was used in fishing line. Of course, smoking was not seen as dangerous, so there was a lot of that sort of thing. And baking products, kerosene lamps. I remember that we always had a can sitting in my garage of gasoline, and my dad would toss some on the charcoal when he was trying to get it started. And then my brother and I decided to play with it and lit the yard on fire, but as we remember, we were very quick to grab the hose and put out the fire. So the thought that we had, easy access to these sorts of things, nowadays there's so much more focus on safety. So it's not as easy for a child of about 10 to get to light their house on fire, much harder to do. Mercurichrome was mentioned in the chat, and let's see. Okay. And then, of course, lye was used in soap making, and I'll tell you a little bit more about that in a moment. And then the medicines, like you said, mercurichrome is an example. Mercury was in thermometers, and when the thermometers broke, you got to play with the mercury. And cosmetics could be all kinds of things. Nowadays, asbestos. Someone mentioned asbestos. Yeah, we didn't know that it was dangerous to our lungs, so we just we just didn't worry about it. I remember that spun glass was used as insulation in my garage, and I just remember my father saying, "Be careful, it's itchy if it touches you." But he certainly didn't worry about me being close to it. This is an old coal furnace, and this shows the guys backing up and shooting the coal down. But at this point, I want to stop the share for a second, and I want to show you what coal looks like, because I'm wondering how many of you have actually seen coal. So I have some here. So this is my parents in 1945, just to set the scene. And this is a piece of coal. This is bituminous coal. And when you burn it, it has a lot of sulfur in it. So one of the pollutants that comes when you burn this kind of coal is sulfur dioxide, which goes up into our atmosphere and combines with water and oxygen to make sulfuric acid and changes the pH of the rain. That's known as acid rain, which is not a musical group. It's actually something that happens in our environment. This is anthracite coal. It's much harder. It burns a little bit cleaner. It has a beautiful shiny look. The difference is this one has been under the soil longer, and so it's undergone a metamorphic change, and it's harder. It's a harder rock. But these two rocks are rocks that burn. And that was what was discovered that led to us being able to harness the energy of coal and basically to fuel the Industrial Revolution. I'll say something about this in a little, well, I'll just say now, because this is kind of fun. And now you've seen it, you might be curious. This here is a bar of magnesium, and this is a piece of flint. So the idea was that you used a knife to carve off little shavings of magnesium, and then you used the striker. Can you see a spark? You used the striker and you could start a fire without matches that way. And, this was more or less practical knowledge that people might have. So let me restart the share and get back to the PowerPoint here. Okay, so moving on. I decided I would try to make some soap. And so I had what I will describe as a soap adventure. Spoiler alert, I was not, wait. Before we go on with my soap story, I want to see what we had. We had a coal furnace until the mid-60s, says Don. Michelle says, I grew up with a coal furnace until I was 12, and we also burned trash, and that was considered normal. Someone mentioned here toilet bowl cleaner as a memory. And super elastic bubble plastic. Oh my gosh, I remember that, but that was later. You're right, that was in the 70s, but that was awesome. That was an awesome toy that's no longer available. Petrol, good. Okay, thanks for those comments. So on to my soap adventure. So I decided I would try to make soap the old-fashioned way. And I started with wood ash. So this is from a fire pit in my backyard, and this is wood ash that I collected. And of course, it's mixed in with a lot of charcoal, which if you don't know the difference between coal and charcoal is burned wood. And what's left behind is primarily carbon, but it's a very low density, porous material compared to coal briquettes, charcoal briquettes, which have been compressed, and then coal, which is formed under high compression and has a much higher density and fuel capacity. But I started with this stuff. And the reason why is because in wood ash, you have something called potash or potassium hydroxide. So the idea is to leach the potassium hydroxide out of the ashes and turn that into lye or something that is chemically similar to lye. So this is what the ashes look like. In the meantime, I'm saving all of my fat from my hamburger, from my bacon. I'm saving it for months and months because I'm not a big meat eater. And so every time I cooked meat, I would just save the fat and collect it. So at some point I had my lye water, which tested out at a pH of 11, which is alkaline, but not as alkaline as lye. Lye would be a higher number, it would be like 13 even. So this is weak. And this is my somewhat cleaned up fat, which the way I'm cleaning it is I'm mixing it with water, I'm heating it till it's melted, and then I'm letting it separate. And every time I do that, and I have to do it several times, more of the bacon smell goes into the water and leaves the fat smelling, having less and less odor. And then came the day when I actually did my soap experiment. And I was so excited when I saw bubbles. I was like, bubbles, bubbles, I'm actually making soap. It's happening. And then what? Well, I'm going to show you what. Let's put this back here. Okay. And we have my soap. Okay. It's not really soap. It's creamy. And it smells like wintergreen because I put wintergreen into it. So it doesn't smell too badly, but it has a slight hint of bacon. A slight hint of bacon. So I figure just a little bit of bacon might be somewhat of an aphrodisiac in some situations. Probably my dog will certainly love me when I use this. And it seems to be a nice cream from my hands. It's actually quite pleasant, but it's not soap. And so what went wrong? Well, what I suspect went wrong was that I simply didn't have the concentration of lye that I would have needed to be successful. The little bit of wood ash that I used was nothing compared to the buckets and buckets of ash that were probably combined with rainwater and left to sit over time and become more alkaline as they sat. Okay, so I want to share with you a little excerpt from a book that was written in 1938 called Chemistry and You. So feel free to read with me or faster than me or whatever, but here we go. On the way home from a picnic in the woods, George picked up a small piece of pipe. One of his companions observingly said, "You always pick up the most junk. What good is it?" "Well," said George, "it's very heavy and it bends easily, so it must be lead. I can use part of it for sinkers on my fishing lines." James, who was in high school, remarked, "We learn in chemistry that there's no such thing as junk to the chemist. He knows how to change it into something useful. Do you see the value of properties? Would you like to be able to make things more useful? Then study chemistry." And here's what the pieces of lead looked like that were sitting on the ground around the filling station, we called it, or gasoline station, 2 blocks from my house. And when I was a little girl, I collected these. I picked them up and I put them into a bag, brought them home, put them in my garage, went into my brother's room, climbed up to the top of the closet with a chair, got his chemistry set, stole it. I never gave it back. I took the alcohol burner out of it and I went into my garage, and all this time, no one knows what I'm doing. I'm all by myself. And I lit the alcohol burner, and the alcohol flame reaches about 212 degrees Fahrenheit. I lit the alcohol burner, and over it, I happily melted my pieces of lead. Lead has a low melting point. It melts at around 621 degrees. So I melted my lead, and then I poured my molten lead, into plaster of Paris molds that I had made from chess pieces. The only problem I ran into is that the way I made the chess piece molds is by pressing the chess piece into plaster of Paris, which was in my garage, and I mixed myself. When I took it out and refilled it with lead, I had only half of a chess piece. The back, of course, was flat. So when I tried to stand them up, they fell over. And so I abandoned making my chess set because of that. But the point is that I was probably 11 years old when I did this. And I was able to access all of these materials without any difficulty. So I put this slide here with a lot of blah, blah, blah on it, which I'm not going to read out loud. But the main idea is that in the 30s, 40s, and 50s, researchers invented a bunch of antibiotics, psychotropics, antihistamines, vaccines, and so on. And at the same time, they began to push against the more natural cures that were the purview of the pharmacist. And so the pharmaceutical industry fought back against this, what they called synthetic medicine, and started to defend the natural medicines that were all around us. Now, it wasn't unusual for people to have little gardens and to grow herbs and to know the medicinal properties of their herbs and plants. And so this is an example of a map that was made in 1932 that was put out by the pharmacy industry to remind people that plants were sources of healing solutions. And they said in that little excerpt that's at the bottom, they said that the plants shown on this map grow natively. And they said that intense scientific study, expert knowledge, and extreme care and accuracy are applied by the pharmacist to medicinal plants and drugs. And then they said something here about, where is it? Here it is. It is important that the public does not lose sight of the fact that the professions of pharmacy, medicine, and dentistry give an essential service which must not be impaired or destroyed by commercial trends. And what those commercial trends were about is the direct marketing of synthetics to the public instead of relying on going to the pharmacist for a medicinal. Now, I said that I couldn't resist a little bit of mention of the effect of, or the way that chemistry and girls were connected during this time. And here's an excerpt from the same book that had our previous character going fishing and picking up lead. So Mandy certainly knew how to make good coffee. It was always clear too. Now, Mandy had a way of her own that many modern housewives might not approve. When making coffee, she placed eggshells in the coffee pot. What happens when egg white is added to cloudy coffee? Now, the idea behind this is that what they were explaining is emulsions. They were explaining the ability of the albumin on the edge of the eggshell to capture particulates and to cause them to sink out of the coffee, to clarify the coffee. And so this is a handy trick that you learn in chemistry, this makes chemistry appealing to girls and as well as the boys when they have examples like this. Okay, hang on a second. This is an excerpt of a movie that was very early. You'll see Jane Fonda in it. And in order for you to hear it, I'm just going to restart the share and click on share sound. This shows an old-time chemistry class. And you'll see, well, I'll let you form your own opinion. Try that again. So there's Jane Fonda. Reaching for the acid above the head.
Oh, I'm sorry. It must have slipped out of my bag.
What is it?
Oh, it's just a list of books I'm going to pick up at the library.
Spengler, Decline of the West, Darwin, Origin of Species. John Dewey, Individualism, Old and New in the Basic Writings of Sigmund Freud. What? I didn't know you were taking all these courses.
Oh, I'm not. I couldn't work them in. But why should that stop me from satisfying my intellectual curiosity?
Notice she poured the chemical back in the bottle, which is something we teach people not to do because of contamination.
Isn't there anything in the world you're not interested in?
Why do you think I came to college? Should we continue the experiment?
Oh, yeah. Now, you're sure that you've mixed the proper proportions of acid and oxidizing agent?
Oh, yes.
This is your campus reporter from the College Station KCUS with a 5 o'clock edition of the news. Well, we don't have to worry about Ray Blent. The word from the infirmary is that Ray suffered only minor burns as a result of that chem lab explosion.
So there you have it. She gets distracted and she causes an explosion in the chem lab. And her role in college, of course, is to find a husband. And that was her attempt at doing that. So not a very flattering look at women in chemistry. All right. And here's another example, but I think you get the idea. This is one where Mary's making fudge. Her boyfriend calls. She doesn't want to interrupt him, so the fudge burns. She wants to clean it, so her mom won't get mad about her aluminum pan. So she finds the nitric acid in her brother's lab, and it works. And now they go on to put the chemistry question, why did nitric acid work on aluminum? And could you use other acids? So another example of why girls need to know chemistry. And here's just a picture of a chemistry class, and you can see the ratio of men to women. And I can't even begin to address the lack of representation here, because it's obvious that this is all Caucasian people, perhaps, maybe some, but definitely minorities are not represented in this mixture. There was a general lack of awareness of danger. Here's someone singing about DDT is good for me. It kind of rhymes. DDT has been banned. It's a carcinogen and a mutagen. Here's someone being told to gargle with flit because they swallowed a bug, and flit's a pesticide, and if you just gargle with it, that'll kill the bug. So there was very little awareness that there would be any kind of serious danger. You could get cocaine for your toothaches. That's something we should probably bring back, right? Cocaine toothache drops. There's days when I could use that. Mercurichrome, someone mentioned it. Mercurichrome actually has mercury in it, and it's mercury in an organic form that could theoretically be absorbed, but we might remember it as that red stuff you put on all your cuts, and it's an antiseptic. And for those women that need to deal with their hygiene, their personal hygiene, just reach for the Lysol. Before Lysol was an industrial cleaner, it was a product used for feminine hygiene. And what about chemistry sets? Well, this is the cover of a chemistry set from the 50s. And there's, you know, the two boys doing their experiments. Here's another one. And both of these I purchased on eBay. So they were shipped to me in a box. And you can see in the box that the chemicals have spilled and mixed with each other. And it went through the United States Post Office mail with no problem. And some of this is a broken bottle here. These are all little vintage bottles. And some of the chemicals in this set, we have sodium ferrocyanide, which sounds really scary, but it's not as scary as it sounds because the cyanide is complexed. We also have tannic acid, which is a fairly strong weak acid. I mean, it's not going to burn through the box, but you can see through here to the metal container that it was in, that this thing was corroded. And so I cleaned it up, made it look pretty, and put all the chemicals in bottles where you can kind of see what we have. And you can see here we have Cobalt Chloride, which you can't even buy anymore. It's considered carcinogenic. And I have a small amount of it. And there was a time when this material was mixed with plaster of Paris, made into a shape of a poodle, and it was put out. And when it was humid, it would turn blue. And when it was dry, it would turn pink. And it was known as the weather poodle dog. And my mother had one of those in her house. This is an experiment that I did from a little book from this old-fashioned chemistry set. And this is the growing of the crystals. And some of these crystals are potentially carcinogenic. This dark blue one is the cobalt chloride. The green is a copper sulfate, which is a good fungicide. And this was where I was going to show you a couple of books. So let me show you. Let's see. Switch to here. And I have here a lab book. This lab book was written in the 1930s. Let me focus here. This is Betty Smith's lab book. And here is Betty Smith writing her name with sulfuric acid on paper. So she was told to do this as one of the experiments. This was first published in 1933 and then published again throughout the 30s. The experiments in here are, some of them you might recognize if you teach chemistry, you might recognize, but some of them we would never, ever dream of doing nowadays. So I'll show you a couple of those. This one here, wait, one page back. This one. This is where you heat the mercury to make the, you heat the mercury oxide in order to produce some elemental mercury and then to test for oxygen, to release the oxygen. So this would not be done in today's modern laboratory. This one is where you blow through a pipe into a flame in order to oxidize some lead. So it's quite the book. It's quite the artifact of things that used to be done, and many of these have been eliminated from our modern course because of how dangerous they are. This one here is, I've been doing experiments in this one just for fun. So this one will teach you how to make gunpowder. It'll teach you how to oxidize various substances. It'll teach you I'm trying to think here. Oxidation of spices. This is one I'm going to show you a video of because I just did that. But these were experiments that were expected to be done with boys from their chemistry kit. You know, like their parents bought them this chemistry kit and they were expected to teach themselves chemistry using the kit. And their father would maybe loosely supervise them, or maybe not. Maybe they would just explore it on their own. And it wasn't seen as a dangerous toy at all. So here's the book I just showed you, 1936 copyright on this one. Within that book, here's a list of things that every home was supposed to have just sitting around. You were supposed to have, you know, plaster of Paris, for example. You were supposed to have your ethyl alcohol, your grain alcohol, your gasoline. Those were just things that were not included in the chemistry set because you should just have those sitting around your house. And now I'm going to play this video. Please tell me if it works or doesn't work, because I will see. This one's embedded, so maybe it'll be different. Do you see a bar moving? Do you see anything? Do you see the magnesium?
Yes.
Okay, so there's no soundtrack to this. This is me putting a magnesium wire in a mixture of spices and potassium nitrate. The potassium nitrate I got from a chemical called Spectracide, which is a stump remover. You can go to the hardware store and you know when the magnesium lights because it's very bright, and then the potassium nitrate will start to burn, and then the spices will oxidize and you will make a beautiful flame. This was one of the experiments in the chemistry set for the boys. Something they should be able to handle. Just read the directions and use the correct amounts. Don't use too much. And there you have it. Here is the actual experiment. Notice the odor like a perfume. So breathe the fumes, no problem. Smoke doesn't hurt you. And there is still a fascination with explosions that hasn't changed. But now instead of having a home chemistry set that your parents know about, you're more likely to just find out on a YouTube channel. There's one that I find particularly interesting called Nerd Rage. No, Phoebe, it didn't say to do the experiment outside. You were probably doing it in your basement. Remember what was it, the Addams Family with Uncle Sylvester, I think, who had his lab in his basement. He was always blowing things up and the smoke would come up through the floor. That was that was probably what was happening. Yeah, bottled water. You know, that's funny, Alicia, you said even bottled water is going to kill us. There's that joke in chemistry that dihydrogen monoxide is the most dangerous chemical on the earth because of all of the fatalities that are associated with it every year. And then you come to find out that we're talking about H2O or water, and the fatalities are related to drowning. So one argues that the dose makes the poison. But now teenagers go to the internet, and you know that experiment I just showed you, my source of the potassium nitrate was a stump remover. I saw this wonderful chat where some young man, some little boy, had gone to the hardware store and bought the wrong stump remover. And instead of being able to make smoke bombs like the internet was telling him to, he had bought one that was based on sulfur and oxygen. And it was quite a different chemical, and he didn't read the chemical labels. So he was trying to make his smoke bombs, which should have been potassium nitrate and sugar, with this sulfur oxide and sugar. And the chat is cute. He says, I bought the wrong stuff. How do I get the smell out of my house before my mom gets home? So he had basically filled his house up with sulfur dioxide. And other kids, you know, they find out on the internet how to ignite aluminum inside of drain cleaner. And no matter how much salt they keep putting in drain cleaners, it still has the sodium hydroxide you need to combine with aluminum to make a makeshift bomb. But this is the chemistry sets we sell today. 35 fun activities, no chemicals. And of course, every scientist here, and especially the chemists, are probably at this point shaking their heads, looking disturbed, and saying things like, of course there's chemicals. The cardboard box is a chemical. The air is a chemical. What are they saying? But these are all the things you can do. You can make magic messages. You can make acid rain. I'd like to see you do that without chemicals. You can make a volcano. Yeah, that's baking soda and vinegar. Not that exciting. So we've become somewhat chemophobic, and we have not learned how to handle the chemicals that are around us, or in many cases, unless you are a chemist, we haven't even learned what chemicals are around us. I'm going to stop the PowerPoint now because we're almost done, and I just want to give a chance for some wrap up. But I do want to say that I've had my students tell me chemical stories, and they have told me things like burning their face with a face mask, or putting bleach in their cat box and finding out that it gave a suffocating odor, or being forgotten in a dental chair under the influence of nitrous oxide. And these are things that are current. I mean, this is my students telling me these stories. And I'm asking myself, and my theme really today is, do we know more chemistry today or less? And of course, you could argue it both ways, right? I mean, if you're trained, you know more than we've ever known. If you're part of the general public, you tell me.